Good morning, everyone. I'm Ms. Rachel, and I'm here today. We're going to talk a little bit about the laws of motion and physics, and we're going to be playing with Legos. As you can see, when I set up these Legos, and they weren't quite close enough. When I topple them over like that, when I push one over, it knocks over the one that goes after it, and that knocks over the one that goes after that. And you've probably seen this before when you've watched videos or seen someone setting up dominoes in a domino rally in real life. And what you may not know is that what's happening is a process called the first law of motion. When something moves, it's going to keep moving as long as no other forces are acting on it. So when I push this cup, it keeps rolling and it's going to roll around and block the camera. Oh, no, it didn't. Haha, very lucky. It stopped because there are several forces acting on it. First, we have gravity. Gravity is what holds us down on the earth. It's created by larger objects in space. We could get into that on another day, but basically gravity is what keeps everything in place but allows them to move. And also the air, the shape of the table, the shape of the cup. If you were to kick a soccer ball on a field of grass, it would keep moving until the grass and the air and the gravity around it stopped it from moving. If you were to kick a ball in a vacuum, it would keep going forever because objects in motion stay in motion until something acts upon them. So, when we set up our domino rally, and I'm going to set it up really far, but I want to make sure everything stays on screen. So we're going to start there. Now, because we have the little Legos, they need to be very close together in order to knock each other over. But if they're too close together, they will get stuck on each other and they won't knock each other over. So you're going to have to experiment a little to see how to get them to set up a rally and to actually knock each other over. And while you're doing this, you might want to set up some stop breaks. That's where you're going to have a hole so that if I knock over my next domino, it only knocks over, oh, see, these two were already too close together. I'm glad we did that. So we're learning. So if I knock over these, they all stop. Do you see that? That's because there's the force here holding them together. Gravity is so strong that it's keeping these holding each other up, even though they're falling over because they're so close together that they stick on each other. So we're actually going to set them up a little bit further apart. But we also want to keep them far enough apart from each other that they have space to fall over so they don't stack up, but close enough that they can actually knock into one another. And then, like I said before, you're going to want to create some stop breaks so that if you knock over your dominoes, they only knock each other over and don't have to worry about knocking everything over. Now, because we're doing this, we want to make sure we have plenty of space here and we can actually make these a little bit further apart because, as you can see, they're longer, they're going to fall further. We're going to leave some space here, though, because we need to put the same size dominoes in between each other. If I put a really long domino in here, guess what's going to happen? It's going to be too close to this one, and they're going to stack together. So we're going to keep winding it around. We're going to watch the reaction that the dominoes make together and see how they knock each other. Oh, wow! Did you see how hard that force acted on the other dominoes? But now these two are too close together and they're stacking up. So this is a very exciting process. And you're going to get to experiment yourself. You've got a bag of Legos. Your Legos should all be about the same size. So you shouldn't have the same problem that I'm having here where they're getting stuck on each other because they're different sizes and they're not sure what the proper way to move is. But you can build and you can make twists so that they go around this way and then circle back in the direction they were heading. And as you can see, I am working on a surface that is not completely even. In order to do this experiment properly, you're going to want to put them on the floor or on a flat table, like a wooden table. My table has a foam edge on it, and that's what's making everything knock each other over. I did get quite a few of them lined up yesterday when I wasn't filming, but of course, whenever you put the camera on, it's going to cause an interesting reaction. So here's what happens when we stagger the sizes and we try to make them different, and this is probably going to work because the time I practiced it with them staggered, it didn't work. And now we're filming and yeah, but fun. And so you're going to experiment, you're going to see how it works, and you're going to learn all about how objects in motion stay in motion until something comes to a stop. So what's stopping them here is that these dominoes were too close together, but also what stops the dominoes when you have them properly lined up is the fact that you simply run out of dominoes and there's nothing else to fall over. They run out of momentum. That means that there's simply nowhere else for the energy to go except that last domino. And when that last domino falls on the ground, it stays on the ground. Because once an object stops moving, it's going to stay not moving until something else makes it move. That's all we have time for today. I'll see you next time. Bye-bye.